In this particular question, an electric dipole placed in a non-uniform electric field can experience. So, electric dipole is placed in a non-uniform electric field. Suppose, first of all, we try to draw the non-uniform electric field over here. So, let this be a non-uniform electric field. Clear? And the field is something like, let it be for a positive charge. That means the field is something radially outward. And here in this particular case, so what we'll be doing, we'll be placing one electric dipole over here. Suppose we are placing this electric dipole, negative charge, positive charge separated by some distance, let it be 2a. So here it is minus q and this is plus q. So what thing is that this negative charge is present at a region in this particular region where electric field strength is more. That means as compared to the charge plus q where it is located. So here electric field strength is E2 and magnitude wise E1 we can say is greater than E2. Here magnitude wise E1 is greater than, if E1 is greater than E2, then the force on this negative charge due to E1 will be towards left. It will be equal to F1 will be equal to Q into E1, but it is direction here we have given, so that's why we are not putting a negative sign. And as this is a positive charge over here, it is present, so force upon that one will be towards right here. So that will be F2 will be equal to Q into E2. And if we compare uh, which one is stronger, whether F1 or F2, as electric field E1 is greater than E2, that means that implies, so we if we multiply Q on both sides, so Q E1 is greater than Q E2 magnitude wise. So finally it will be equal to F1 is greater than F2. So magnitude of F1, magnitude of force acting on negative charge is greater than magnitude of force acting on the positive charge. So this is the reason why the dipole will start moving towards left. So that means net force is not zero. So net force over here is not zero. So a force. So what will happen? Then can experience a force but not torque. So force, it will experience the force. Yes, obviously it is experiencing a force. Net force is not zero. F net is not zero. Clear? And whether it will experience torque or not, yes, definitely it will experience a torque if it is placed by making some angle theta. Clear? So what it is said is that the dipole placed in a non-uniform electric field can experience. Okay, similarly, second one, a torque but not force. That is not possible, and because force will be obviously there, always a force and a torque, so that or force, so that means here this particular it is saying that force will be there as well as torque will also be there, and fourth one is neither force nor torque. That is not possible, either option A or option C, a force but not torque. Clear? Here as angle is not mentioned, so that means we cannot say that torque will not be acting. Clear? If angle is zero, then torque will be zero. So again, option A is wrong. So then now we'll go to the option C. Always a force and a torque. If force will be there, then here in this particular case, as it is not mentioned about angle, so torque will also be there. So option C will be the correct one.